So I've gone over some of the assignment ones that I've seen turned in. For the most part, everybody did pretty well. I'll officially grade those pretty soon, but in general, I'd say everyone did pretty well and had as far as their paragraphs go, a pretty good understanding of things. So I won't spend too much more time on review. I'll start moving forward here, and so. Last time I started to talk about classes a little bit, so I'll move on with that topic. Uh, right after classes, we'll move into some of the actual data structure stuff, but it makes things a lot easier to deal with data structures if you kind of know some of the C++ features, and one of those features is object-oriented programming. If I tried to do this class in pure C, where I didn't have some of this stuff, it'd be a much more difficult class to teach. So what we have to do is kind of introduce a topic before we can really get into the data structures. And just so you have a high-level overview, I did a video on the data structures we'll be dealing with in this course. So let's dive right in. I will start a new project in Visual Studio. And then I'm going to have under Visual C++, General, an empty project. And the first thing I'll do is just add a main.cpp. So let's do that. Main.cpp. And then I'll make that a little bit bigger. Let's do the typical, I'll make it one more. Okay, that should be good enough. We'll add the typical stuff. IOStream, this is just kind of boilerplate, so you get used to typing it every time. Okay, so everyone should be good with that. Now let's go to header files, and we're going to create a new header file. And for those that haven't worked with header files so far, and COP 2000 or just in general, basically a header file is like when we do these includes right here, we're basically pulling in header files. A header file is basically pulling in external code. It's a little more difficult like that, but I want to kind of keep it simple for everybody right now because the process actually gets really complicated really quick. So I'm going to do this in a way where we can really focus on the data structures and not so much the complexities of C++. So I'm going to add a new item, and this is going to be a header file. And this header file is going to contain everything for our first object-oriented C++ class. So, and you'll kind of see what this stuff means more in a minute. I'll show you first, and then I'll define it, because if I define it first, it'll be a little vague and kind of not make a whole lot of sense. So first thing I'll do is we will make a car class. So car.h, and I'll do that with a capital C, and then I'll click add. Okay. So I'll just type some stuff, and then I'll explain what all of it means. Oh, and let me make this bigger. I think this is the same size. Okay. Okay, so this might look a little familiar. So far what I've done is actually created almost something sort of like a struct. Basically I have something called a class called a car, and I'm giving it a bunch of fields, a bunch of members. And so we have the number of wheels, and then with with classes, we can actually set it to a default. And there's another way to do it with something called a constructor, which we'll go over later in the course, but I don't want to confuse you too much. So first thing we'll do is we'll create a class, a car, and then we'll give it a bunch of fields. We have a number of wheels, we have initial gear. We'll say 0 is park, and then -1 will be reverse, and then 1, 2, 3, 4, 5, 6, however many gears we want to have the car max out at. And then we'll say the gas tank level is between 0 for empty and 1 for full, so we can kind of still keep in mind floats and everything. And then so we're gonna have a string, and that's gonna be a color, and then we're gonna leave that just let's set it to have none for now. We'll say it's an empty string initially. Okay, so if we were to use this, we're basically just creating a struct pretty much so far. And so you can see that. Oh, let me do one thing. And so what we have to, let me erase this. The first thing we have to do is, since we're dealing with multiple files now, we have to actually include our car. And so see, we do the angle brackets here. That's because that's a system library. When we're bringing in header files that we've created ourselves, we have to use double quotes. So we say include and then car.h. So I hope you kind of understand the difference. So this is IOStream is a part of the C++ standard library, and there's a slightly different way of bringing that in. So when we're bringing in our own header files, we use the double quotes. So nothing too complicated there. And so before, when we were using structures, we had to say struct and then the name of our struct and the name of our instance. Now we're just going to say car, and we'll just name it C for short. And so now we have a fully functioning car. So if we wanted to do a cout, and then we'll say C dot, say the gas tank level, then we can just start without debugging. Oh, let's add one more thing. If you remember here, this just keeps the DOS prompt open for us. Okay, we can, and let me make this a little bit bigger. Let's make it 24, 28, so you can see it. Okay, so you can see it's at 0.5. So basically, we've really just used this as a struct so far, and we haven't done anything too crazy. Let's start adding things here. So, and don't worry about what that public is. We're going to be working with public and private. For the most part, things will be public, and I'll get more into that later. But for now, we can just stuff everything into public, so that's fine. So let's go ahead and create a function within here. So before, with structs, we couldn't really put a function inside of a struct. So now we can, let's say we'll have shift up. So we're going to shift the gear up, and then we're going to say gear plus plus. So that just means to put the gear, so if it starts initially at 0, it'll go to 1, and then when we call it the next time, it'll go to 2. And so this is kind of interesting because let's make sure this still compiles. Yes, we still compile. Okay, and it's probably giving me a green squiggly and saying this is a bad idea, and we'll get into later separating out the actual code and our. So they have the definitions and then the implementation, and typically you want to separate those things out. But we're all going to put it into one big file right now, just to make things easier. I want you to understand how this stuff works before we get into the details. So we've put a function inside here, and this is kind of interesting. We can, before with a struct, we couldn't do anything like this. We'd have to pass a car inside of a function to get to that gear. So before we would have our struct and all the struct's members, and then we'd have to create another function, and then if we wanted to shift the gear, we'd have to pass a car as one of the function arguments, and then we would access the gear through that. Say we used a pointer, and then we'd have to dereference it and go through all this stuff. But now we can just say shift the gear, and so let's say, so initially we want to see the gear, so we say C dot gear, and so initially it'll be in 0, and then we will do, the syntax is just like this. So we want to do C shift up. So I hope that syntax makes sense. And then now we'll see what exactly happened to that gear. So initially the gear was at 0 the first time we called this, and then we shifted the gear, and then now the gear is at 1. So this is kind of cool. We don't have to deal with all kinds of passing around all kinds of pointers and functions, and so what I showed you before is the kind of the C style. If you're working with a bunch of C code, you typically see that style. So now what I've gone ahead and set up is a class, and the class can directly access its members via a function and modify those members. So this is kind of cool. This is something we didn't really see before, and I don't want this video to run too long, so I'm just going to add a couple more here so you just sort of get the general sense of what's going on. So we're going to say shift down, and then we're going to say if, because we don't want to go past, let's add some checks. We should really add some checks to shift up, but let's go ahead and start by adding our constraints and our checks to shift down. So we want to say if the gear is, we'll say if it's greater than -1. So we don't, So if the gear is greater than -1, that means it's not in reverse. So it's either in park or some other gear. So we don't want to let it ever get to below -1. We want -1 to be sort of the floor of that. So we say if it's greater than -1, we're okay because we're in park or in some sort of drive gear. We'll say gear minus, and then let's do something similar with this here. So we'll say this is if gear is less than 6. So the most we'll be able to shift it is into, so if we get to this and the gear is in 5, that'll match, and then so we'll shift up and that'll put the gear in 6, so we'll have at most 6 gears. And so in this case, if the gear is 0, then we subtract, it'll be a -1, and the next time we try to shift down, it won't match, and so it'll just go on. So just a little bit of logic there. Think about it for a minute. Pause it if you need to understand this logic. Okay, so we have some shifting. So let's go ahead and let's this time we'll shift down, and then we'll make sure our checks work. So we start at 0, and then now we shifted down. Let's try to shift down again. So just do a copy and paste. So now we start at 0, we shifted it down to -1. We try to shift again, and it should not work. It should just stick at -1. Oh, and then we got to actually do a C out to show. And let's save it and start without debugging. So start at 0, we shifted down, and then we tried to shift down again, we couldn't. There are things called exceptions, if anybody's heard of those, that we can get into later to handle that. For now, we'll just kind of put a lower limit on that of how we can shift. And so, but really the point is now that we have this cool new thing that kind of acts like a struct, but it's a lot simpler to use. And let me go into one more topic that'll just talk about the names of it. So when we talk about object-oriented programs, so we have a class C, and then we have an instance of that class. Or I'm sorry, we have a class called car, and then we have an instance called C. So when we say car C, we have an instance of a car, and then so when we modify it, we're not modifying the original car. We're just basically modifying an instance of it. And so at any given point, our class class instance, our C, will have a state and it has behavior. So when we first create that instance of the class, it has a state, and so the state is all the defaults that we gave it right here. And so this is the state. And so we start modifying the state with these functions, and these functions are what's known as behavior. So I'll get into that a little bit more in another video. That's kind of the theory behind object-oriented programming, but I just kind of wanted to give you some working knowledge on how exactly all this works. So come up with your own examples, just start getting used to the syntax and how all this stuff works, and then coming soon here I'll make some new videos and kind of a little bit more advanced usage of classes. So just try to come up with your own examples of cars and robots and animals and any sort of real world object that you can come up with turn into a class.